Hello everyone, myself Sugnan Shivayogi Abhigiri. Today we are going to solve a previous year JEE-MAIN's question. This question appeared in 2020 JEE-MAIN paper. So let us have a look at the question. Effective capacitance of parallel combination of two capacitors C1 and C2 is 10 mu farads. This is the parallel combination of two capacitors C1 and C2 and their effective capacitance is 10 mu farads. Effective capacitance means the resultant capacitance obtained when these two capacitors here are in parallel combination, and the resultant capacitance given in the question is 10 mu farads. We measure the power of capacitance, or we measure capacitance in terms of farads, or here we have used mu farads, means 10 power minus 6. Then moving ahead in the question, when these capacitors are individually connected to a voltage source of 1 volt. Individually connected means we are breaking down the two capacitors from this circuit, and separately we are connecting them to a voltage source of 1 volt. Voltage source means any battery. So we are connecting them to a battery of 1 volt separately. Whenever we connect any capacitor to a battery, some kind of energy or some energy is stored in the capacitors. The question also says that the energy stored in capacitor C2 is 4 times of that in C1. If these capacitors are connected in series, their effective capacitance will be. So we need to find what will be the effective capacitance or resultant capacitance when they are connected in series. First, they have given a parallel combination, and also we have been given the effective capacitance. Whenever two capacitors are connected parallelly, we will get the effective capacitance by simply algebraically adding them, like C1 plus C2 is equal to 10 mu farads. This one is only applicable for parallel combination. That C1 plus C2 is 10 mu farads. We neither know C1 nor C2. So let us keep them as it is and name this as equation 1. The question again says that they are connected individually to a battery. Now this one is C1 capacitor. This is a battery of 1 volt. This is C2. This is a battery of 1 volt. And the energy stored in capacitor C2. Here we need to know the formula of what will be the energy stored in the capacitor when a battery is connected. So let me write it here. Energy stored in capacitor. We represent this energy stored in capacitor with the letter capital U, which is equal to half into C into V square. This is the voltage connected to the capacitor V, C is the capacitance, and U is the energy. So for C1, for capacitor C1, U1 is equal to half into C1 into V square, right? Because voltage is same, 1 volt 1 volt, so we need not to mention separately that this one is V1, but we don't know about anything about capacitance, so I'm writing this simply as C1 into V square. This is the formula, so we are applying here. For capacitor C2, the energy will be U2 is equal to half into C2 into V square. Question says that energy stored in capacitor C2 is 4 times that in C1. So energy stored in capacitor C2 is U2. According to the question, let us write it here. According to the question, energy stored in capacitor C2, which we represent it as U2, is equal to 4 times that in C1. 4 times into energy stored in C1, that is U1. Now let us put the values here. U1 in place of U1, U2 and in place of U2. This is half into C2 into V square. This one is 4 into half into C1 into V square. Here half and half get cancelled. We get C2 into V square. V is 1. We have connected voltage 1 volt. V is 1 square. Or we could have directly cancelled because we have connected the same voltage, 1 volt, 1 volt. So, but let us do it like this only. C1 into 1 square. C2 is equal to 4C1. Let us write this one as equation 2. Put equation 2 in equation 1. Means we will put the value of C2 in 1. That means that C1 plus C2 is equal to 10 mu farad. C1 plus 4C1 is equal to 10 mu farads. Let me write it here. C1 plus C2 is equal to 10 mu farad. C1 plus 4 into C1, which is equal to 10 mu farads. C1 plus 4C1 is equal to 5 into C1 is equal to 10 mu farad. Now we get C1 as by sending 5 to that side, we get 2 mu farad. Now we have obtained the capacitance of C1, that is 2 mu farad, or 2 into 10 power minus 6 farads. Now let us also find the capacitance of C2. We know that C2 is equal to 4 into C1. C2 is equal to 4 into C1, which is equal to 4 into 2 mu farads, right? So C2 will be equal to 8 mu farad. So we got the capacitance of C1. We got the capacitance of the C2. Moving to the last segment of this question. If these capacitors are connected in series, their effective capacitance will be. So let us connect them in series. This one is C1. Series means we are continuously connecting them without any division. Parallel means we have divided the wire and connected them. But in series we are connecting them jointly, or one after the other. Now here, if capacitors are connected in series combination, we need to reciprocate them and add them, or I can also write it as the formula for it. C1 by C effective is equal to 1 by C1 plus 1 by C2. This is the formula to be used only in series condition. If parallel means we will directly add it like we done here, but in series condition we need to do like this. So let us find out by putting the values. We have C1 here, we have C2 here. So let us find out. 1 by C effective is equal to 1 by 2 plus 1 by 8. Taking LCM, we get 4 plus 1 divided by 8. This is equal to 1 by C effective. 1 by C effective is equal to 5 by 8. Finally, C effective is equal to 8 by 5. So C effective be equal to 1.6 mu farad. This one is the answer, final answer for this question. So let us look this answer in the options. Yes, the first option is here, 1.6 mu farads. This is the right option for this question. First we had a situation of parallel combination. We find out a equation. Then we have situation when we have individually connected to a battery and energy stored. So we got these equations. We have related them here, and we got the capacitance of two capacitors as 2 and 8 mu farads respectively. So after analyzing these two equations, we got the capacitances, and finally we have put in the series connection formula or series combination formula, and again we have got the final answer. Hope you enjoyed solving this question and you have also enjoyed this video. Please share this video to share the knowledge, and please subscribe my channel to get my previous year competitive exam questions solutions. If you have any doubts in this solution, you can use the comment box to convey it to me. It will be my pleasure to clear your doubts. And have any question that needs to be solved, please put that one also in the comment box. It will be my pleasure to help you. I will cover that question in the next upcoming videos. So thanks for watching this video. Thank you one and all. Stay home, stay safe. This is Sugnan Shivayogi Abhigiri signing off. Thank you one and all.